All right, welcome to Module 3, if statements in C#. In this module, we're speaking directly and more specifically about decision structures. So, what are decision structures exactly? Well, decision structures, they're a method by which we can ask a question. If something is true, then do this thing. If it's not true, then do this other thing. Or maybe we just ask to see if it's true. Now I'm using the word if here because that's the first thing we're going to talk about, right? So a decision structure involves choosing between alternative courses of action, like we just annotated. All computer decisions are true or false. Now, what's interesting about that is even at the processor level, that's also true or false. No matter what you do, is always going to be a truth C or a false C statement, right? And that might sound very binary. And the reason why is because it is. We want to know if it's a 0 or a 1. We want to know if it's on or off. I understand that most things are very complex, but if you divest away from complex thinking and you melt everything down, boil all the water away, and you look at a specific problem, that problem can be quantified in a binary set. This is the rule of discrete mathematics. Everything can be quantified within a binary set. And that binary set is always true or always false. If you get an outcome that is neither always true or always false, it is molecular in structure from a high level way of thinking. If we applied chemistry to the understanding of chemistry with the understanding of computer science, please understand that if you have not gotten down to a binary equation or a binary outcome that's either true or false completely, one or the other, then you still, within the scope of the chemistry analogy, you still have a molecule. You have not broken that molecule down all the way to its atomic form. Once you have, you will literally get to this point. Either it is or it ain't. Either it's 0 or 1. Either it's true or it's false. Either it's on. This is the pièce de résistance. Either it is on or it is off. That is it. This is a concept that, as I've been teaching over the past decade to a decade and a half, I've found to be very hard to explain at the collegiate level, only because I think we, as a society, are looking for a concrete, complex answer. But in the end, we need to get down to the grassroots, get down to brass tacks, and find out what's at the bottom layer. So, the most widely used decision structure in all programming languages, doesn't matter which one you use, is the if statement. Yes, there are some contrarians out there who will argue with me regarding this specific statement. But at the end of the day, the if statement is the most widely used decision structure in all of computer programming. And it's used to do something very specific. Now here it says used to make a single alternative decision, but really what an if statement does is it creates it asks you to create a Boolean expression that asks the singular question I was just talking about in the last slide, which is the thing you are testing true or false? If it's true, then we will run the code block you possess. If it is false, I will then go down that stack. And if there's an if else or else after you in this branch of if statements, then I'll run that instead. Or I will compare, determine, I'm not saying the right word, it's in my head. I will evaluate. There you go. I will evaluate the Boolean expression. So what's the block of code? If the Boolean expression, or if the if statement, so this is the if, right? If the if statement's Boolean expression, which is between these parentheses, if it's true, it's going to run the statement within it, right? And normally that statement is encapsulated in curly braces. And that's really it. So, oh, wait, actually, no. And another one. You can do what's called nested ifs, which is an if statement within an if statement. Back in the day, I say back in the day, I'm really 10 to 15 years ago, this was a common feature of programming, and separating concerns between two different Boolean expressions is important in certain situations where those cannot be combined. But in most situations, we don't do nested ifs anymore. We try our best to keep the if statements in a single layer. Nested ifs can become a mess, especially from a understanding of the dependency model of each if statement, right? If so, for instance, you can have an if statement that says, if your shirt is white, then you are allowed to enter the establishment. But inside that, if the shirt is white statement, right, for the true statement, enter the establishment, there might be another if that says, if the shirt has a collar, you are allowed to enter the establishment, right? Those two if statements are asking two separate questions. The first Boolean expression or question, the first evaluation, the algorithm we want to ask is, are you wearing a white shirt? And then the next if statement is asking the question, are you wearing a collared shirt? Now, those aren't the same thing, and I can understand why somebody would want to split those out for whatever reason. But in the end, why can't you ask the question, if you are wearing a white shirt, and if you are wearing a shirt that is collared, then allow them in. You can do them both of them at the same time, instead of having two if statements, and this is actually more efficient. There are situations where you want to do a nested if, where you have an if statement within an if statement. The analogy that I just gave you is most analogies or most examples. And in that situation, whenever I'm doing a code review and I see if within an if, I always try to combine them. Always. It's just an efficiency game. It's less that the computer has to read. It's less the computer has to compute. It's less the computer has to ask a question why. Every time you ask a question why, or you query a storage location, such as a variable, that is processing time. That is literal processing cycles. You want to delay, you want to keep that at a minimum as much as you possibly can. So with that being said, let's code. So I'm going to bring down my REPL, and I want to really go over the if statement again. So we did this in the last module where I had to write an if statement to try parse, but let's talk about what it's doing, right? So if int.tryparse x out first number, what is that doing? Well, what it is doing, we ask the end user for a value, but we know that the data type of that value may not be the data type we need. So we need to check to see if it's the right data type. So in order to check, we're using the method tryparse. Now you might be asking, well, hold on. Is that method doing anything? Actually, it is. What it's actually doing, we don't care, right? I mean, as a programmer, we do care, but like how it does it, we don't care. We want the method to return back to us a true or false. Hey, is this an integer or not? That's what we want. That's the part where I say I don't care what's actually happening inside the tryparse. I care about what it's doing, right? It's trying to determine if the integer or if the value that we provided it, the variable that we provided it, is it an integer data type, right? That's what this X is. If it isn't, what will happen is this tryparse will return false. Now, how is it doing that? Can anybody tell me? I will stop and pause for a second. How is it returning that? What data type does it need to be to return that? You can pause and do some research, go back and look at another module. Well, if you've paused me and turned me back on, here's the answer. Int.tryparse is of a Boolean data type, because Booleans are representative of a true or a false. A Boolean in and of itself is a primitive value that is known since it was been used since time immemorial as otherwise known as a byte or a bit, right? Because it basically just means, are you true or false? It's the smallest data type that we can conjure, and as such, we use it constantly. And in this case, the tryparse is going to determine whether the value of the variable or the data type of the variable x that I passed to it here, is this variable an integer? If it isn't, then it needs to say false. Can it be converted? Can it be parsed to an integer? Not is it an integer? Can it be parsed to an integer, right? If it can be parsed to an integer, then this will be true. And when it's true, whatever's between these curly braces is going to execute. Now, what's interesting is I have an operator here, right? So and literally means this, right? That's the int dot triparse first number, this first one. So this and that, which is this next int dot triparse, right, must be true in order for this if statement to fall into the block. So this has to be true and that has to be true. If I wrote this more simply, it would look like this. If first number equals 1. Right? Cool. We're going to say console.writeLine. And we're just going to do something, sweet. Something that makes a little bit of sense, right? So if first number equals 1, right? And we're just going to put a 1 in there so you can see how this works. Right. Now, I wish I had Visual Studio up because then I can debug this and show you what's actually happening. I think I will do that in the next video. But what you'll see down here is it's going to print the value sweet. But what you're not seeing is that when this evaluates, okay, first equals 1, what it's actually doing is it's asking whether or not the first number equals the value of integer 1. That's what it's asking. If that is true, if what's on the left side of the double equal signs equals what's on the right side of the double equal sign, then it will be true and sweet will run. So sweet will be written. There you go. Sweet was written. There it is. That's this line right here. That was written because first number equals 1. What happens when I have another thing I want to check. Let's say I want to throw a value when it is never 1. Well, then I would say else. Now, what this means is if first number does not equal 1, then everything else, all of the other cases, need to fall into this branch. Now, this is not something we write a whole lot. As a matter of fact, I would argue very strongly we do not write else statements if we can avoid it at all, because there's never a situation where all of the other cases are going to fall into this else. And that could be a massive issue. So, but just know you can write else. And then there's if or else if. Now, else means everything else, but else if means if the first one or the branch above me, if that is not true, when you fall down or when you fall through, right? So let's say this is not true. When you fall through, then fall through here, and let's do another Boolean expression. Now that first number is equal to 2, all right? I'm going to move this out of the way because it's kind of making it hard to read. Right, there you go. As a matter of fact, I'll just erase this. I don't really care about that anymore. All right, here we go. If first number equals 2, all right, then write else. So this should write else because first number doesn't equal 1. But what's going to happen is the program is going to evaluate the first if branch and then each subsequent if branch after that, whether it's the else if or the else. And yes, you can write a truckload of if statements after this if you want. There's the else string that we printed at line 11 if this Boolean expression was true, right? And this is where I really want to stop. There's only one other thing that I want to explain, which is logic operators. Not in detail, but very quickly. If I want to check to see if the value on the left-hand side of the expression is the same as the value on the right, if they equal each other, I will use what's called equality, which is 2 equal signs. 1 equal sign means assignment, right? So I'm assigning the variable or the value 2 to the variable first name. But here at line 7, I'm not assigning the value 1 to first number. I'm sorry, not first name, first number. I'm not assigning the value of 1 to first number. What I'm actually doing is I'm checking to see if the value of 1 is also the value that is assigned to first number. And that's what these 2 equal signs mean, equality. So 1 equal sign means assignment, 2 equal signs means equality. And there's the vaunted 3 equal signs. That's not necessarily found in C# and Java, but you can find it in JavaScript. And what it does is it's not only checking for the equality of the variable, it's also checking to see if the data types match. So in this case, first number was false, and therefore it fell through. But let's make it work, right? You can do a negative expression as well. If I did bang sign equals or exclamation point equals, you're not going to even see exclamation point anymore. It's bang sign. So bang sign equals means is not equals, does not equals. So bang sign means not or is not. Equal right after it means exactly that, equals. So what is this saying? If first number does not equal 1, and what this should do is this should actually print the value sweet, because first number does not equal 1. And something interesting is going to happen. When the first if statement runs, if it determines that it is true, it will not run any of the other if statements. Because if you think about it, both of these Boolean expressions match. First number is not equal to 1, and first number is 2. But because this first one was hit first by the program, the second one won't run because the if statement has been satisfied. The whole dang thing, all of it. If there was an if, else, if, else, if one of these is true, if any of the branches are true, the if statement will not run the other branches because those other branches can't be true to the if statement. I've satisfied my requirement. This is where things get silly. This is why we try to keep our if statements simple, because you run into a situation where somebody could write code like this, where you have 2 if statements that are literally doing the same thing. You're just not writing them in a way that they're doing the same thing. And that is as far as I really want to go. There are other expressions. Let's say you wanted to check to see if first number is greater than or equal to 1, or if first number is greater than 1, or I'm sorry, that was less than. If this is greater than or equals to. In SQL, this actually means is not equals to, but in C# it is bang sign equals. These are all of the logic operators you're going to need when you're writing your Boolean expressions and if statements and other decision structures if you so desire. So I want to pause here. I don't want to keep going. This is a micro lecture. I'm getting excited. I want you to know that this is really exciting for me. I'm having a lot of fun doing these videos. It's taking me some time because I want to do it right. I want to give you all the information that you're going to need. So don't sweat the small stuff. And as I say in all my videos, good luck. Have fun. Ciao.